Welcome all. Today what we are going to learn is about relative velocity. The definition wise, relative velocity is the velocity of one object with respect to another object. So it is the velocity of one object with respect to another object. Okay, this is the definition of relative velocity. So if you want some examples, we can say the common example that we experience in our daily life, that is for example, if you are traveling in a bus, if you see outside or if you see the road, you feel that the road is moving backward. You are moving forward and the road is moving backward. You are feeling like that. That is because it is a relative velocity. Actually, you are feeling the relative velocity of the road. So one example if you want, I can say when a person sitting on a bus which is moving, the bus is moving, he see that road is moving backward. This is due to the relative velocity. This is due to the relative velocity. He observes like that. And second example, if you want, we will consider another beautiful example. That is, we will just consider there are two trains which are moving on two parallel tracks. Okay, two parallel tracks are there. Two trains are moving. They are moving in the same direction, and you just see here, two parallel tracks are there and two trains are there. Just imagine these two are the trains and they are moving in the same direction with the same velocity. Then if a person is sitting on any one train, person observes the other train, he feels that the other train is at rest. Actually, for us, when we see both the trains from outside, we feel that both the trains are moving. Okay, but if a person sitting on one train, if he observes the other train, he feels that the other train is at rest. That is because of relative velocity. Okay, the same factor, relative velocity. So we will write that a person sitting on one train seeing the other train which is moving on a parallel track, like this, and it is moving in same direction, it's moving in same direction with the same velocity, he feels that the other train is at rest. The other train is at rest. So what is it? A person sitting on one train, seeing the other train, which is moving on a parallel track, and it is moving in same direction with the same velocity, he feels that the other train is at rest. This is due to relative velocity. So we got two examples here. One is when a person sitting on a bus which is moving, he see that the road is moving backward. This is due to relative velocity. And the other example that we quoted here, this one, that is also due to relative velocity. Okay. So this is what we have learned today is the definition of relative velocity and examples, two examples of relative velocity. Yes, so we understood the definition and examples of relative velocity. Now we are trying to write equations for relative velocity. So for that we will consider the situations of two trains moving along two parallel tracks. So I will draw the situation now. That is, just imagine these two are parallel tracks. Two tracks are there, and you just imagine there are two trains. One train is here, another is here. Say this is train A and train B, and just imagine they are moving with their own velocities. Say VA and VB are their velocities. So I'll write here VA is velocity of train A, and VB is velocity of train B. Okay, and we consider this is the actual starting point, and from there they start and they move along parallel track. And when we start observing both trains, the time we take it as 0 second. The time here is 0 second, and these are their initial positions we observe. When we start observing, these are the initial positions. They start from their original positions, but we start observing at 0 seconds, and we will consider the initial positions, what we observe at 0 second as these positions. So that are XA of 0 and XB of 0. These are the positions from where we start observing the trains, two trains. Okay, they are moving with their respective velocities, and say after some time t, they reach their positions as this is A, train A reaches after t seconds. Now the time is t seconds, and it reaches XA of t, I will consider, and the train B reaches here, that is again after t seconds, it reaches here, and I will consider this position as xb of t. Okay, xb of t. So they are moving with their respective velocity. Again, I am remembering you. So with the VA, it is moving from here to here. With the VB, it is moving from here to here. So what is the displacement? What is the displacement of these two trains in time t second is the question now. So what is the distance moved from here to here? What is the distance moved? That is actually when I am considering, I'll say it as XA of t, it is moving. So from here to here, it is XA of t. From here to here, it is XB of t. Okay, but we need what is the displacement from here to here, from xa of 0 to xa of t, and from xb of 0 to xb of t. What is the distance? Or oh, sorry, what is the displacement? Okay, here both distance and displacement are same, so I can even say distance. So here that is, I will consider this displacement is, displacement is given as the product of velocity and time, velocity into time, isn't it? That we have already learned. By this basic equation, we can say here the displacement is nothing but displacement of this one, which one? Train A, that is between xa of t to, that is x a of 0. This displacement I am saying, that is VA into t, isn't it? Yes, correct. So similarly for B, the train B, xb of t minus xb of 0, it is nothing but VB into t. This time is same, So these are the displacements of respective trains. So from this, I will take this as equation 1 and this as equation 2. From equation 1, I can write x a of t, this is from 1, okay, x a of t equal to, what is it? I'll just bring this x a of 0 to the right hand side, so it will be x a of 0 plus v a t, isn't it? Yes, correct. So x from equation 2, x b of t, what is it? That is, I'll bring this x b of 0 to the right hand side, so it will be x b of 0 plus vbt. Okay, so from these two equations, I got equation for x a of t and x b of t. What are these? These are nothing but the distance from here to here and here to here. Okay, the actual displacement from the original position, not from the point where we are looking from. It's not from that point. It is from the origin itself. Okay, I got equation 3 and 4. So what is my intention is just to say the equation for relative velocity. I am doing this situation. Okay. Next, what I will do is I will just perform as 4 minus 3. Equation 4 minus equation 3. That will give me x b of t, isn't it? Equation 4, x b of t minus x a of t, that is the left hand side. I am deducting the left hand side first. That is equal to what is it? Right hand side. xb of 0 minus xa of 0 plus, what is it? Within the bracket I am writing VA into T minus, VB here, VB into T minus VA into T. Okay. Right. Yes. So T is common here, so I'll write it as XB of 0 minus XA of 0 plus VB minus VA into T. So I got this equation. So what is it actually? It is nothing but this displacement, this distance, that is from here to here. What is it? That is what I got now. Okay. The distance between the final positions of train A and train B, that I got now. Okay, so here what we got here, VB minus VA. VB minus VA, the difference between the velocities, that is what you call as relative velocity. So I will write VBA equal to VB minus VA. This is the relative velocity of train B with respect to train A. Okay, this is the relative velocity of B with respect to A. Okay, relative velocity of B with respect to A is VBA, that is VB minus VA. Okay, similarly, if you want the relative velocity of A with respect to B, we can write it as VAB, isn't it? That is equal to VA minus VB. This is the relative velocity of A with respect to B. Okay, so these two are the equations we got for relative velocity. Okay, so this is the situation of two trains moving along parallel track. By taking this situation, I am explaining what the relative velocity, actual fact of relative velocity, and I got an equation for relative velocity. Okay, so this is what we learned in this particular video.